it can still be hard to distinguish a star's exact attributes. They appear in a variety of shapes and sizes. Some of these are massive, while others are tiny, whereas others are barely moving. There are several instances in the cosmos where things defy rationality. The sun is amongst the most boring celestial bodies. For the time being, our middle-aged sun is pleased with its existing size. However, the sun will expand to the proportions of a red giant within only a few 100 million years, and will continue to shed its outermost layer until it is reduced to a scorching white dwarf engulfed by a spectacular planetary nebula of brilliant gases. But, fortunately for us, we won't have to wait nearly as long to see these events unfold with our own star, because millions of similar events occur all the time around us. To find them, we simply need to look in the appropriate direction. Hello there, and welcome back to the Discover Space channel, where we explore cosmic life, possibilities, and many more. UY SCUTI is the biggest known star in the universe. In 1860, German astronomers at the Bonn Observatory first cataloged UY SCUTI, at the time naming BD 125055. During a second observation, astronomers realized it grows brighter and dimmer over a 740-day period, leading to its classification as a variable star. Researchers, like their comic book counterparts, sometimes discover that prefixing something with the adjective super underlines its status as truly exceptional. The largest known star in the cosmos, UY SCUTI, belongs to the category of supergiant stars. UY SCUTI has already shed a large amount of weight, which is remarkable. Hypergiants can grow to be 1,000 times the size of the Sun. The star lies near the center of the Milky Way, roughly 9,500 light-years away from Earth. Located within the constellation Scutum, UY SCUTI is a hypergiant star. Hypergiants, larger than supergiants and giants, are rare stars that shine very brightly. They lose much of their mass through fast-moving stellar winds. The huge radius of UY SCUTI does not make it the most massive or heavy star. R136A1, which has a mass of around 300 times that of the Sun, but a radius of only 30 solar radius, takes the prize. In comparison, UY SCUTI has a mass of around 30 times that of the Sun, but a much larger volume. Because UY SCUTI does not stay the same size comparisons are much more difficult. Just how many suns exactly could fit in UY SCUTI? Well, we have about 6,520 trillion Earths could fit in the same space occupied by UY SCUTI. To put its scale into perspective, a jet traveling at the speed of light would take 14.5 seconds to round the Sun, but the same thing would take 7 hours to circle UY SCUTI. There are as many as 30 stars whose radii fit within the minimum estimated size of UY SCUTI, so it shouldn't be too comfortable on its throne. Although the Sun is depicted in the center, it is not large enough to give off a noticeable spot. UY SCUTI, a red supergiant star with a mass of 5 billion suns, is one of these extreme stars. If the number of Earths that can fit inside UY SCUTI is too large to fathom, the number of suns that can fit into UY SCUTI might be a better option. All stars, like planets, revolve around a center point. For planets, this is the central star, which is the Sun. Because the Earth's typical distance from the Sun is around 150 million kilometers, this count would be about 25 meters distant. UY SCUTI's photosphere would extend a little beyond Jupiter's orbit if it replaced the Sun at the center of the solar system. On the other hand, intrinsic variables like UY SCUTI go through physiological changes like pulsations. Because of its unpredictable growth, the brightness of UY SCUTI varies, making a precise measurement of its circumference challenging. UY SCUTI, like every other red supergiant, will die in a spectacular manner. It will fiercely form bigger and heavier materials after the helium fuel within the core gets depleted. UY SCUTI will eventually begin to manufacture iron if it does not release too much mass during its lifespan. Whenever a star merges two iron nuclei, it does not produce the same amount of energy as when it merges lighter elements. Rather, it consumes energy from the environment. As a result, the star goes into rapid collapse, where it can no further withstand its own gravitational force. What then would be the final outcome? UY SCUTI will be seen to the naked eye for the first time from Earth due to its powerful core collapse Type II supernova. Well, that was one amazing discovery, don't you think? Let us know what other cosmic adventures you want to take on next, and we shall see you then.